When graphing this parabola, the first thing I notice is that the variable being squared is y. So I know this parabola opens to the left or the right. The second thing I notice is that this parabola is not centered at the origin. If it was centered at the origin, it could be written as y squared equals 4px, or x squared equals 4py. Like in example 1, this one right here could have been written as x squared equals 4py. We can't do that with this one because we have a binomial on this side. So let's start by solving it for y squared. If we add y squared to both sides, we're left with 4x equals y squared plus 20. Now if we subtract the 20 from both sides, we get this. And I'm gonna flip the sides here just so I have my y squared on the left side of the equation. It's a little easier to read that way. Now the next step I'm going to do is factor out this 4 because I see 4 can come out of the 4x and the negative 20. And this last step's a little weird. I'm going to rewrite y as y minus 0. Those are the same, so we can do that. And the reason I did that is because now we have it in what's called vertex form. Vertex form for a y squared parabola is y minus k squared equals 4p times x minus h. And this will allow us to find where the vertex is and all the other characteristics. So when we line things up, we see that k equals 0. The next thing we see is that 4p matches with the 4. So the value of p must be 1 in this case, since 1 times 4 is 4. Finally, x matches with x, the negative with the negative, and the 5 with the h. So the value of h is 5. Now here's what hk tell us. They tell us that the vertex is located at 5, 0. So if I go over to here, my vertex is at 5, 0. So if I go on the graph, 5, 0, 1, 2, 3, 4, 5, 5, 0. Next, using the value of p here, p equals 1, and noticing that it opens to the right because p is a positive value, we know the focus is going to be located at 6, 0. That's 1 unit over. Now the directrix is going to be 1 unit to the left of the vertex. So the directrix is located, let's see, this is 5, 0. So 1 unit over would be 4. So it would be located at x equals 4. Finally, the axis of symmetry always runs through both the vertex and the focus. So the axis of symmetry looks like it's the x-axis in this case. So that is y equals 0. The last two things we need here are the x and the y-intercepts. Now the x-intercept's pretty easy since the vertex is located right on the x-axis. The x-intercept is 5. Now the y-intercept, looking at this graph, we know the parabola is going to open this way because it has to, eat the focus. And the directrix is right here. So it doesn't look like it's ever actually going to intersect with the y-axis. So the y-intercept is none. So the only thing we're missing at this point is the actual parabola. So let me rewrite where we were on the other page. We got to y squared equals 4 times x minus 5. Now we have to choose a value of x carefully here, something that when we apply it to this side of the equation, it will be easy to take the square root of. So if this whole side, for example, equaled 4, that would be a good choice for x. So for this side to equal 4, this parentheses right here would have to equal 1. So a good value of x to plug in would be 6. Let me make an XY chart here. All right, and we'll put our vertex because we know we have a vertex at 5, 0. All right, let's plug in a 6. 6 minus 5 is 1. 1 times 4 is 4. So what numbers could we square to get a 4? -2 and 2. So 6, -2 is on the graph. That's right here. And 6, +2 is on the graph. That's right there. So if we connect those with the vertex, we get our parabola.